Tech Report, a podcast with news and information on big data and high-performance computing. Today, my guest is from ZL Technologies. We have the co-founder and VP of Business Development, Mr. Steve Chan. Steve, I'd like to welcome you to the show today.
Thank you. Thanks so much, Rich. Thanks for having us.
Well, it's really great to have you, Steve. You know, we do a lot with big data here. Everyone's talking about the coming wave, the tsunami of huge unstructured data and everything else. So you guys have an interesting set of technologies going on here. I've brought your slides up. Why don't we start with that?
Sure. No, absolutely. So we've kind of identified a way that customers and companies can really identify with what we see is not really a coming disaster. It's really something that's been happening. It's this doubling disaster, we feel. It's kind of like an anti-Moore's law, where instead of computing doubling and increasing in performance, we're seeing technology pretty much doubling every 2 years. And this was corroborated by some of IDC's research as well as something out of Gartner. So it's not just one analyst that was predicting doom and gloom. It really was something that we're seeing across the board, across pretty much every industry. So I thought I might say real quickly a little overview about what ZL and who we are, and then we can get into the disaster proper, as it were.
Sounds good.
So we've been around going into 13 years now. We were formed in 1999. And we've been profitable for some time now. But our focus really from a product perspective has always been around really scalable problems or problems that benefit well from scalability or scalable solutions. And the big part of what we've seen in terms of need really have been from customers that are really concerned about risk management and specifically around things like e-discovery, records management, compliance and governance, and all of that wrapped together into a really efficient storage management or content management, if you will. From the perspective of this discussion and what we see, our big value proposition is our ability to scale. And because we're able to scale, we're able to unify everything. All of the data that you would look at from an unstructured view, emails particularly, but also SharePoint data, file data, anything across the network, social media these days, everything that you might bring together to be managed and searchable in very, very fast order. A variety of analysts cover us, but really from the types of customers that we support here, a few customers, they tend to be very, very large. They tend to have a lot of risk. They tend to be heavily litigious or serial litigants, if you will, and also heavily governed. Lots of regulatory hits on them. And lastly, we have a variety of different partners that get us into the cloud or get us into more big data or big databases, et cetera, across the world. So in terms of the doubling disaster, as we said, the reality is that digital data is doubling every 2 years. And worldwide today, we're seeing the total amount of digital data in the order of 2 zettabytes, and that's 1 billion terabytes. That's a lot of data, and no matter how you slice and dice it, and it's not going away, right? It's only increasing. And so the key challenges that we see with archiving this kind of information and managing it are really twofold. One is scalability, and the other is having flexibility, having something that can treat that data, manage it in different ways. So let's look a little bit closely at scalability. The first thing is we ask our customers, do they understand how much data they actually have or what kind of scaling problem do they actually need to engineer for? And we take a real simple metric. If you have a medium, large-sized company, 25,000 employees, and you look at a 7-year retention period, and we're not trying to be too complicated here, you multiply that out, and you get around 4.5 billion documents for that type of a system or solution to both index, store, and search. If you compare that to some number out there that you can really respect, when Google IPO'd, they announced that they would index 4.28 billion web pages. So for a company that, there's not a huge number of 25,000 person companies, but there's a fair number of them. You're already getting into the range of a Google-sized problem in your back office. And so the truth of what you're trying to create here is pretty stark. It's not a casual thing. And many of the different kinds of solutions or technologies out there start to stress and have problems when you get into high volume. You may not see it in the beginning, but you do want to be worried about it because as you grow, it will become an issue. So let me put a little bit more points on it. If we define big data the way that ZL would, we look at it from the standpoint of some of our current customers. We have a large financial institution. They've got a range of documents that come from different mergers or post-merger, different levels and types of documents coming from legacy uses that are stored around in a variety of ways. Well, we gather all this stuff up, and we've indexed and ingested all of it, and we've come to about 7.8 billion documents for just one customer, okay? Now, if you compare to this, and I did a little homework for you, and today I checked what the estimated size of the indexed number of pages in the World Wide Web, this is the entire internet, if you will, you're into 8.04 billion web pages out there indexed. So truly, we're talking about big, big numbers. You don't have to be in the cloud to get big. It can be right in your back office, okay? So if we continue to look at this a little bit in more detail, when we look at the size of these repositories, and we're looking at the second line down here, it's not just your legacy data, right? It's not just what you have in the past or what you're trying to get caught up with. It's really the advance and your production data, and as it increases, which is really scary because for a lot of our customers, they're looking at 49, 50 million documents a day. And this is largely email, but social media, tweets, if you will, those are actually a lot of the data that's coming up. And it doesn't matter how big the volume is per document or record. It's really about the number of them, right? So just the count in the numbers is enough to push these systems into a stressful environment. The next challenge, apart from scalability, is flexibility. So if we look at how this ties back to our premise, we feel that scalability affords this. It affords you flexibility. If you can scale, then you can do a lot of things. And a scalable system will deliver you the function and the flexibility that you need. If you can't scale, your engine, your processing, your core isn't going to be powerful enough to do much of anything. So when we look at that, we start to identify sort of historically what enterprises have needed. And archiving and its surrounding ecosystem has evolved pretty dramatically. In the very beginning, it started off as a storage management concern. You're trying to reduce TCO, cost of storage, minimize that. But then came additional problems, and these came at a 10x cost in terms of complexity, sophistication, and engineering requirements. And these are things like corporate governance, compliance, being able to search quickly, to be able to perform more aggressive types of control. And that evolved into legal discovery and management. Situations where here, again, in the U.S., we have such a litigious environment, especially between large corporations, that every case can be worth millions of dollars, and it makes a lot of sense to do a good job there. And then companies would deploy yet another solution for records management to prepare for governance, to prepare for subsequent litigation, or for from a government perspective, you'd have issues around storing from a NARA requirement and being able to save things for appropriate life cycle and then dispose of them appropriately as well. And then lastly, bringing everything together now, people are looking at content management. Because we have so much data for our employees and end users, it's very difficult for them to be productive. And so we need automated systems to help them categorize, automated systems to allow them to search and restore on their own and really take the burden off of IT departments. But what we found is that even though all the customers through the course of history have put together all of these solutions, ideally they would have something that would eliminate the risk of exposure for all these copies, and from a TCO perspective, bring it together so that they had one consolidated, yes, unified point for everything, so that you'd had one data copy, you had one policy, and one place to manage and control all of this information. From a functionality perspective, we're really not trying to be picky, right? We can do any kind of data. Our goal is really to look at, and let me specify more around unstructured data, we're really looking at expanding and continuing to expand the kinds of data that you can do it for. And this makes sense. So starting with email, and this is just several of the email systems that we do. Google, we do any of the SendMail systems, any kind of SunMail, Oracle Beehive, including the ones shown here, Exchange and Domino. This is dominant enterprise-based. From a document management system, there are a variety of different solutions like SharePoint, Lotus Quicker, but going into file shares and file systems, really so many different data types that you're talking about. And lastly, getting into social networks. The truth is, these aren't the only data types that are going to evolve over the next 10 years. There are going to be more kinds that are coming up. Of late, it's been social media, but it could be something else next year. Whatever it is, it's going to be added to these kinds of archives, and it had to be able to support and scale that, go into the cloud, present it as well, to be deployed in the cloud as well. Ultimately, though, once we get it in the system, whether we do it through a direct capture and index or we index in place, you want to be able to apply a whole host of different functionalities. And these, again, cover areas of e-discovery, records management, compliance, and storage/content management. And so to be able to capture it, you need to have a scalable system. Once you have a scalable system, you're going to be able to unify all these functions in one and create a one-stop shop for all of these different capabilities against your data. Again, one data copy, one policy, and then one process. Lastly here, in this last section, I want to give an example of how scalability affects a real-world example. So, for example, with scalability, e-discovery is totally revolutionized, and we're just taking one segment, obviously a critical one, but taking one segment of what we do in e-discovery and showing how scalability changes how people do things. So today, for e-discovery, it's very slow. It's very costly. Most of the time, customers are taking their core data. If you can see on the left-hand side your whole raw data set, and we're taking a cue from the Raiders of the Lost Ark, and that warehouse that has all the data. It's basically what most of our big companies have for their storehouse, or at least that's what they think they have. They have to export and import into separate tools each time they take a step through the e-discovery reference model, right? And that costs time and money. Every time you do it, it costs time and money. And you're only going in one direction. And each time you do it, you step down in terms of the amount and volume of data that you have, but you're letting go of any data that you came before it. And so really you're cutting your bridges each time, but you are reducing it, you're minimizing that data, and ultimately after a period of several weeks to months, you've got your production set. Okay, now if you could scale, how would you change that? Well, with a unified discovery model, we feel it's revolutionary because we take that whole warehouse of data that you have, and instead of exporting it out of the system into a secondary, tertiary, or quaternary tool, you're really keeping it in the same place, in the same platform, never letting go of it, and only modifying and altering the metadata as it goes. And you're effectively culling down the data each step as you would normally, all the way down to reduction, but you never let it go. So what happens is this totally cuts down on the costs and time of export and import, each of those delays, so that instead of talking about weeks or months, you're talking about literally seconds or minutes to do each of those steps. So I would say that's revolutionary. And lastly, because it's so fast and because we never let go of it, if you ever make a mistake, if you ever, let's say, now suddenly need additional custodians into your production or your case, or you have new keywords that you need to search against, because we've never let go of that full archive, in a matter of 10 seconds, I can pull in all that new data without having to go through that export process. So truly bidirectional workflow, which, again, nobody else can do. So I've talked a lot. I apologize for the rambling, but I wanted to give you a chance. If you've got any questions, I'm more than happy to answer them.
Well, sure. Well, thanks for that, Steve. You know, this idea of metadata. I wasn't really familiar with how your thing worked, and it seemed analogous. I don't know if you're familiar with video editing, but it's with
Sure.
Final Cut.
Non-linear. It actually, that's a really good analogy.
Yeah, so all the data sits there, all the video files, and then I'm manipulating and cutting and moving things around, but it's what they call non-destructive. So it's just taking metadata and pointing at different parts, and I can arrange that anyway. And yet over on the left, that pile of video source is never really touched. It's just when I hit export that it puts out this little pile that's in the nice, neat stack that I want, arranged the way I want it to be. Right?
That's a perfect analogy, and we would use it more often, but not everybody understands nonlinear editing and non-destructive
Sure.
editing. So but you hit it on the
Yeah.
head. Well,
Yeah.
we've talked about it internally.
Sure. So, how is that metadata generated then? Because you showed all those different kinds of file types, and some might be little text files or log files and all this. Is that what your software does? Does it automate that cataloging and metadata creation?
So what happens is when let's take that last example, the e-discovery process and that workflow. When we start culling out the data, we want to know the metadata we might add there is, okay, who did that search, right? Who saved it into that case? What time did we do? What were the search parameters that we used to cull that data down when we put it in the case? And then we can also add metadata to the case itself through the UI. The user is able to tie in, issue codes that are relevant. They can tie in custodians that are relevant to it. They can tie in certain keywords, et cetera, and start to apply litigation holds and things like that. All that we consider metadata relevant to that work product, that data. But the raw data is never modified, right? So it's just metadata upon which we're adding that additional information.
Sure.
And that's being added through the application itself.
Yeah. So, and you mentioned some partners that I would have thought would have been competitors, like Oracle, for example. I mean, isn't that what they do with a database? They stack up information into nice columns.
Well, sure. If Larry had his way, I think that everything would go into a database. But the truth is that semi-structured, unstructured, or semi-structured data, like an email, it's not ideal to just shove into a database, right?
Right.
Because email has attachments, and email can be 2K, it could be 10 megabytes or more, right? Databases don't like that, right? So what we do in the archive is really we leverage the capabilities of a database, okay, for the metadata. The metadata is very consistent in size, but that metadata itself points to the raw file, that file being an email or an attachment or a file document, et cetera. And so we do, Larry's happy, Windows SQL Server we use as well, but we use Oracle and et cetera, et cetera. But you can use that database to facilitate the addition of metadata, to change the metadata as you're doing e-discovery or as you do different compliance edits, et cetera, or review notes, et cetera. But you don't want to put raw data into the database. And so it is actually part and parcel of what we do, and so that's why Oracle, in fact, Oracle has an OEM relationship with us. They do have the capability to sell our technology under the Oracle label.
Sure. Well, then, how is the engagement work? Is your model here, is that disruptive? Like if somebody has been storing data forever, right, and needs to meet compliance, how does ZL come in? Do they have to start over from scratch and move it over?
So what we've done is we try to make that change process as simple as possible. So we've created tools that can pretty much go into any data either natively, or in the case of other archiving technologies or solutions that they have, we can natively go into those archiving solutions, and we have all the tools built into our platform to draw that information out. And in many cases where that solution exists for compliance purposes, and they've done review and they've done a lot of metadata input already, like they flagged it as, okay, this mail is okay, or this document is okay, we will in fact move that metadata and populate our fields and our application with that same information so that they don't lose any of that work product.
So, Steve, kind of a wrap-up question here. You're a
Sure.
technologist. You helped found this company.
And
Where's this stuff going? Does it become? Does even the metadata become unmanageable at some point as this grows?
that's a great point. I think that as we see some of our larger deployments grow, the database sizes are pretty big. But we that's why we don't play in the database market space. We rely on those guys to continue to make those products strong and improve the database. But really, from an architectural standpoint, we've also have capabilities of stretching out, expanding the system so that given the existing technology we have today, we're still going to be able to scale big because we're leveraging a small amount of storage on the metadata side against a truly large amount of raw data on the raw data side, and we can continue to grow that way. But technology is going to continue to have to evolve because there is more data. Existing data types are expanding, but we're going to have more data types as well. And there might be a point in the future where it's going to be really challenged. But that's why this is great, right? With technologists need problems to solve, and look forward to those kinds of issues.
Yeah, yeah. Well, Steve Chan from ZL Technologies, I want to thank you for coming on the show today.
Thanks so much. Thanks so much for having us, Rich.
Okay, well, it's been my pleasure. Well, folks, that's it for the Rich Report. Stay tuned for more news and information on big data and high performance computing.